help from Centaurs, which is another mythical equine quadruped. And the Wizard of Oz. Here is Greg Detre from Channel 4. He's their chief data scientist. Round of applause.
Afternoon, everyone. So when I say cheat at data science, what I mean is how can we figure out whether something's going to be possible and perhaps figure out whether it's even worth building, and then perhaps make it a much easier problem that we can tackle without making it into a 10-year R&D effort. So that's the goal. That's what we mean by cheating. We'll talk a little bit about how Centaurs and Wizard of Oz are going to help us in that quest. So firstly, I'll tell you a little bit about my own illustrious career cheating at data science. Firstly, I trained as a computational neuroscientist, putting people in brain scanners to try and understand why we forget things. I scanned my own brain. It was smaller than I'd hoped, but it was there at least. From there, I co-founded a company called Memrise, which is one of the largest language learning apps in the world. And finally, I've helped The Guardian build out their data warehouse. I'm the chief data scientist at Channel 4, and I'm now moving into independent advisory work. So let's start by figuring out what we mean by data science, because it's a confusing term that people mean many things by. If you consider a spectrum where on the left we have decisions using data to help us make better decisions, and on the right we have data products, that is to say, algorithmic, standalone, machine learning products that generate business value on their own. So we can talk through some examples. Analytics and insight, dashboards, A/B testing are all in the aid of decision making. Whereas self-driving cars, optimization, recommendations, personalization, even forecasting are all examples of data products. And there's inevitably a bit of a gray area in the middle. I'm going to be talking primarily about data products, that is to say, the right-hand side. Algorithmic, machine learning, standalone data products, and how we can make sure that we build the right ones and that they are of value and make it as tractable as possible. So in order to think about why data science can be a bit tricky, perhaps the easiest thing to do is to compare it to traditional product engineering. So traditional product engineering, building a website, building an app, B2B, B2C, you need some software engineering, obviously, and you need some domain expertise and product expertise. Okay, that makes sense. As soon as you try and build a data product, in a sense, you have all of those problems of picking the right thing, managing your technical debt, writing bug-free code, project management, all of that. And on top of that, you have to worry about the computational, statistical, machine learning, scientific side of things. So it's a superset of the problem. And those computational, scientific, machine learning bits add their own complexity. If anything, they compound the difficulty. So I guess the critical goal that I'm going to suggest is that if, when you're trying to build a data science product, you allow it to become a research problem. And by a research problem, I mean something open-ended that you might study in academia, something where you don't know for sure whether it's possible or indeed how best to tackle it. And the thing about a research problem is, though it's intellectually really interesting, there is the chance that you actually might not succeed, that it might not be possible within the state of the art, and indeed, that even if it is, it could take years. And you don't know how many years, which is an unpalatable thing I've found to tell people in business, because their timelines are usually much more constrained and they need much more predictability. So our goal is to make sure that our data products don't turn into open-ended research problems that might take years and might not work. Okay. So let's start by asking for some help from the Wizard of Oz. This is the Wizard of Oz in all of his emerald Technicolor 1939 majesty. And in order to understand why he's helpful, let's talk through an example. So imagine you're building an AI-powered, chatbot, NLP-tastic travel agent. And that anyone can sort of tappity-tap into this app and say, hi, I'm trying to book a flight to Athens for 8 days or so at the end of August. I'd like to leave at a civilized time and minimize carbon impact. Okay? So it would be pretty super, you think, if you could say that, and it goes, oh yeah, no problem, it's 9 a.m., okay, and you're like, oh yeah, great, and what kind of carbon offset would you like, blah, blah, blah. Wouldn't that be a fantastic experience, you think? And you think, you're so sure of it that you don't even worry about whether this is going to achieve product market fit. In fact, you go the easiest way to determine whether you have product market fit. As everyone knows, the shortcut is to raise £10 million in venture capital, hire a team of 70 data scientists, spend 2 years, build the thing, and then find out if people want it. And indeed, if you think that is the easy road, then I invite you to take it. The alternative, or at least the only way that I know of to avoid spending £10 million and building something really, really amazing and hardcore that may or may not actually work and that people might or might not want, would be to use the Wizard of Oz technique. And so if we recall the Wizard of Oz, that's what he looks like on the outside, but behind the scenes, there is a small man who landed in Oz by accident from Omaha, and he's twiddling a bunch of knobs and talking into a microphone, shouting, you know, pay no attention to the man behind the curtain, because the dog has pulled the curtain behind and you realize, oh my God, that really fancy, impressive-looking display is actually secretly just a little man behind the scenes. Okay, so how can that help us with our app? Well, perhaps you're already seeing where this is going. You could build your magic AI travel agent, or you could hire a small man from Omaha to sit behind the scenes, and when people interact with your Wizzy product, he is secretly, or she, the person who is providing the experience that the AI would. Okay, and in some sense, this is obvious, right? And it might even seem so obvious that it doesn't bear thinking about, except that there are so many advantages, and this so often goes undone, that it feels worth really emphasizing. So perhaps the biggest advantage is it's much easier to iterate on a Wizard of Oz product. You can just say to the person behind the scenes, by the way, can you try this? What if we experiment with testing a variety of different hypotheses? So we could ask, what are the hypotheses, what are the assumptions underlying our Wizzy AI travel agent? Well, we think that it would be great if it was immediate. We think that it would be a real benefit because it's 24/7 available. We think that the fact that it's so easy, that you don't have to learn a new interface, that you can just use human language, that's going to be really, really valuable. And of course, it's really flexible. So rather than being constrained by the options you've got on your website or app, you can ask it anything. Okay, so these are our hypotheses. At least the first two, well, actually, you can get those already from a website or app. So it's really 3 and 4 that we're interested in. And by having a human being pretend, we get both of those benefits. We get easy and we get flexible. And indeed, we can start to test. We can titrate, for instance, how immediate it is. Right? We can say, OK, we're going to try and respond to everything within a minute. Actually, we'll also try responding within an hour or within a day. And then we can measure customer satisfaction. That will enable us to determine whether immediacy is really important. And if it turns out that people don't care whether it's 5 seconds or 5 minutes or an hour, well, you just made scaling an awful lot easier. In other words, you can figure out what the subset of the problem is that is most valuable to the audience, to the user, and then make sure that you nail that. And anything that isn't critically important to them, you can let it go. And of course, there are lots more hypotheses that one could test. I'm just suggesting that once you start to think of this in scientific terms, then you can ensure that when you do eventually choose to spend your 10 million and build this product, that you're building the right version of it, perhaps even a simpler version than you'd intended, and that you can be confident that people will want it once you have created it. But you still would have to build it in this case. I guess I'm going to talk now about the second half of that, which is how can we make the building easier? And for that, we will turn to Centaurs. Centaurs, as you may know, are the half-human, half-horse creatures from Greek mythology, the sons and daughters of Ixion and Nephele, who was made in the image of the goddess Hera. And I think their relevance to data science speaks for itself. But if anybody hasn't already made the intuitive leap, let me talk through a story. So, in 1997, Deep Blue thrashed Garry Kasparov, the greatest chess player at the time, at chess. And you might have been forgiven for thinking at that moment, that's it for us monkeys. What's interesting is that 20 years later, the best chess player in the world, well, it's obviously not a human, but it's not a machine either. It's a centaur. That is to say, a hybrid team of a human with access to a gigantic computer and database with lots of computation to try loads of moves. In other words, there's something about the combination of humans and machines that is greater than the sum of their parts. So Centaur teams are better than either humans or machines on their own. And there's a sense in which I think Centaurs will follow a fairly predictable pattern. So at first, back in the day, Garry Kasparov was the state of the art. Then Deep Blue came along. Then we realized, okay, actually a Centaur is even better. And over time, you can imagine that the ratio of human to machine, human to horse, might adjust, and that over time, it'll be more and more dominated by the machine. But even after 20 years, on the most black and white problem, literally in the world that you can imagine, chess, perfect information, deterministic, straightforward, turn-based, like even in a really black and white problem like that, we are still finding that humans plus machines are greater than the sum of their parts. This kind of blows my mind, because I would not have predicted it. Okay, what that also means, by the way, is in much less black and white problems, in much more rich and human problems, we can expect that the age of the Centaur, where the Centaur team is the state of the art, to last for a really long time. So let's talk a little bit about some, oh, and by the way, of course, using tools to augment ourselves is not new, but the idea of focusing on algorithms as a form of kind of hybrid tool is, I think, at least something we haven't fully thought through. So let's talk through one example from Channel 4 in the real world where we've been using it. So, as you may know, TV advertising is sold in a particular way where it's really important to know the demographics of your audience, that is to say, who will be watching, what proportion of the people watching at 9 p.m. on Saturday in 6 weeks' time at this particular ad break, what proportion of them are women aged 16 to 34 who work behind a desk. That's the way TV advertising is sold, and it's worth real money to be good at that forecasting problem. Okay. Now, for the last 15 plus years, Channel 4 has had an expert human team who do a pretty great job of this. The question that we were interested in is, can we, if we include a bunch of modern machine learning techniques, improve on that? So the first thing we set out to do was to try and solve it with machine learning only, just to see what would happen. And we got close to parity with the human team, but it would have required an enormous investment and an uncertain time period where we may or may not have improved on it. So instead, once you decompose the problem, you realize that actually, sometimes, if you've got a peak show with a high volume of users, brand new, not really like anything particular before, it requires an enormous amount of human ingenuity and imagination to figure out, okay, that's kind of like this meets that. I reckon, therefore, we should predict this figure. It's really hard for machines to do that. Whereas there's this whole long tail of repeats of long-running shows where we have loads of data where the machines actually can do a much better job, and indeed it isn't cost efficient for the humans to spend an enormous amount of time. So you can immediately see how there's a pretty clear division of labor, a pretty clear complementarity. And so that's the work that we're engaged in right now, is to say, can we set up a hybrid system that is the best of both worlds, that enables the humans and the machines to complement each other? And you can imagine it getting a bit more advanced. You can imagine that the machines might flag when there's a really big discrepancy, that they might do a good job of explaining why they think that this figure will be the way it is, so that people can potentially adjust it. You might use active learning, which is a form of machine learning, where the machine gets to ask for help occasionally, right? All of these are the kinds of techniques that I expect we'll see lots more of as we start to treat lots more problems as Centaur problems, where suddenly what was impossible or very hard at least becomes tractable. Okay. So I guess where I want to conclude is to say, these are two of the most kind of intuitive techniques for how to make data science much more like traditional product engineering, where you stand a fighting chance of estimating how long something's going to take and then building it reliably, rather than an open-ended research problem. Because once it is, it becomes very hard to marry the timelines with real business problems. I guess I've had the joy of being able to work on problems like this across a whole bunch of different companies, from startups to larger companies. And I will just say that I'm looking forward to helping a number of other companies build up their data teams and their data products. I'm moving on to becoming an independent advisor. We just won Best Data and Analytics Team of 2019 for the Channel 4 Data Science team, so it feels like a good moment to drop the mic. So if anybody is building up a data team or a data product, I'd love to hear from you. Thank you very much indeed.